The Blackbody Spectrum Simulation is an interactive educational tool designed to help students explore and understand the principles of blackbody radiation and its relationship with temperature. By providing a hands-on approach to investigating how the blackbody spectrum of an object is affected by its temperature, the simulation offers a comprehensive learning experience that covers fundamental concepts in physics and astronomy. The simulation allows students to discover the relationship between the temperature of a blackbody and the peak wavelength and spectral radiance, providing insights into the behavior of thermal radiation. Blackbody radiation is the thermal electromagnetic radiation emitted by an idealized object, known as a blackbody, which absorbs all incident radiation and re-emits it in a characteristic spectrum. The Blackbody Spectrum Simulation begins by introducing the concept of blackbody radiation, explaining how the spectral distribution of the emitted radiation depends on the temperature of the blackbody. The simulation provides an interactive platform where students can actively engage with the concept of blackbody radiation. By adjusting the temperature of the blackbody, students can observe how the spectral distribution of the emitted radiation changes. This hands-on approach helps students gain a deeper understanding of the principles governing blackbody radiation. The Blackbody Spectrum Simulation allows students to adjust the temperature of the blackbody and observe the resulting changes in the blackbody spectrum. As the temperature increases, the peak wavelength of the emitted radiation shifts towards shorter wavelengths, and the spectral radiance, the amount of energy emitted per unit wavelength, increases. Conversely, as the temperature decreases, the peak wavelength shifts towards longer wavelengths, and the spectral radiance decreases. By adjusting the temperature, students can discover the relationship between the temperature of a blackbody and the peak wavelength and spectral radiance. The simulation allows students to visualize the spectral distribution of the emitted radiation as a function of wavelength. The spectral distribution curve shows how the intensity of the emitted radiation varies with wavelength for a given temperature. By observing the spectral distribution curve, students can gain insights into the characteristics of blackbody radiation and the relationship between temperature and the emitted spectrum. The simulation also provides a visual representation of the color of the emitted radiation, which changes with temperature. As the temperature increases, the color of the emitted radiation shifts from red to orange, yellow, white, and eventually blue, reflecting the shift in the peak wavelength towards shorter wavelengths. This visual representation helps students understand the relationship between temperature and the visible color of thermal radiation. The simulation provides an interactive platform where students can actively engage with the concepts of blackbody radiation and its relationship with temperature. By adjusting the temperature and observing the resulting changes in the blackbody spectrum, students can gain a deeper understanding of the principles governing thermal radiation. The visual nature of the simulation makes abstract concepts more tangible. Students can observe the spectral distribution curve and the color of the emitted radiation in real time, helping them to grasp complex ideas more easily. The simulation offers immediate feedback, allowing students to see the results of their adjustments instantly. This helps correct misunderstandings quickly and reinforces learning through trial and error. The simulation covers a wide range of topics related to blackbody radiation, including the relationship between temperature and the peak wavelength and spectral radiance, the characteristics of the spectral distribution curve, and the visible color of thermal radiation. This comprehensive approach helps students gain a holistic understanding of the principles of blackbody radiation and their applications in various fields. The Blackbody Spectrum Simulation is a valuable tool for teaching and learning about the principles of blackbody radiation and its relationship with temperature. By providing an interactive, visual, and comprehensive platform, it helps students understand how the blackbody spectrum of an object is affected by its temperature and discover the relationship between the temperature of a blackbody and the peak wavelength and spectral radiance. Whether used in a classroom setting or for individual study, this simulation can significantly enhance the learning experience and build a strong foundation in physics and astronomy. Through exploration and experimentation, students can gain a deeper appreciation for the complex and fascinating world of thermal radiation and its applications in various scientific and engineering fields.